implementing subcycling inside CarpetX. Uh, so this morning, Eric talked about this new driver of Cactus CarpetX, and it has a lot of features, good features. So what we want to ask is actually how does it perform compared to the old Carpet? So here I show EPH simulation, this 9 level of mesh refinement, and the scaling test. And these 3 lines correspond to 3 different simulations. The blue and the red are Carpet, and the green is the new CarpetX. And because it's not apples to apples, and the Carpet ones using the FICO zone to evolve the magic, and the CarpetX right now we only have a one zone, so we use a one zone to evolve the magic. And so the difference between the red one and the blue one is using now using subcycling inside Carpet. So
Liwei,
yeah,
the y-axis is higher, better, or worse?
Sorry. Higher is better. So this is physical time per day, basically how many amp you can get every day. So the higher is the better. And the x-axis is the number of nodes of Rochester machine. So as you can see, so if we compare both the subtype case of Carpet and CarpetX, actually right now the Carpet one is a little bit better compared to the CarpetX because the FICO zone has a lot of optimization inside, and but the difference between the subcycling and the non-subcycling is much significant compared to the FICO and CPC. Yes.
So I assume that the CarpetX one is also no GPU. Is the CarpetX version using the GPU or not?
Here we are only showing the CPU.
Okay. Yeah.
I will show GPU later.
Okay.
So basically, what we want to ask is that because this gap between subcycling and non-subcycling is higher, we want to fill this gap first before we tuning the stability zone or write that new cycle zone inside CarpetX. So basically, that's the reason we want to add subcycling inside CarpetX. Okay, so I want to remind you first about this from the CADA method. So basically, if you have an ODE with data, you can prepare 4 sub-steps. I will call it Y1, Y2, Y3. Correspondingly, you will also have 4 sub right-hand side, K1, K2, K3. And you can, after you prepare these sub-steps, and you can combine this sub right-hand side to construct the value of next time step. So inside Carpet, this is how we implement the subcycling. Here I show a case of 3 different measure different requirements. This is the most coarse one. This is fine one, fine one. 3 different resolution, different levels, and the coarsest levels have time step data t. So this is time t equals 0. This is next time step of the coarsest one, t naught plus data t. And the second coarse one will have a smaller time step data t, and for the even fine one, we have the smaller time each level will have different time step size. Um, so to be more specific, so if you want to evolve the first time step of the finance level, just as we said previous slide, we are using RK4. So we need to prepare basically 4 sub-steps before we can get to the next time step. And let's go back to the RK4. So when we try to solve Einstein equation, the right-hand side F actually contains the spatial derivative operators. So whenever you try to evaluate F, you will using a finite difference operator, which means you will need ghost point to ghost stencil to evaluate the right-hand side. So in order to prepare these sub-steps, you will need this ghost. So in the end, we want a function value at here. But in order to evaluate from the previous substep to the final time, we will need an actual ghost point before we can evaluate the app. So, but in order to get this point, we will need another ghost point from the previous subtime step. And the same thing for the previous steps. So in CarpetX, actually we have a buffer zone. Basically, you have, if you are using RK4, then you will need 4 times of the boson size buffer zone. And if you have this, and you initialize this buffer zone at t equals 0, and you start evolving and throw out all this throughout all these points, which are not suitable anymore, then you will get to the first substep. But if you want to go to the next substep, then you will refill this buffer again. But the only way the way which implementing CarpetX is still in this buffer zone using time integration between from the core side of the grid. Right now we actually have 53 time levels to do this time integration to build in this buffer zone. So it's only 7 on algorithms like CarpetX. So it is the same level, and basically subcycling CarpetX. So the next question we want to ask if we can improve the algorithm, because they require 4 times of the boson size, and it's a lot communication between the refinement parameters. So if we want to ask, we can decrease the number of points. So because this value we fill in order to get to the next level is actually coming from the courses level, and so we can. So what we want to ask, we can come up with a better way to build in this forms will be used to get to that. So in order to achieve that, let's go back to our table method. So instead of using the previous buffer zone method, we can actually doing a Taylor extension of this case, and then around this Tn, basically doing Taylor extension of this expression of f, and replace f with y prime, y prime prime. We have these expressions. And because of, as you can see, the y's are the y1 equals yn, y2. South stage basically have a very simple relation case. Instead of doing a Taylor expansion of k, we also have Taylor expansion of y. And right now we have y's. The south state can be represented with the yn and y prime. Basically, the yn and derivative of y. So because this y south state is what we need at this those points before we move forward. So the next question is, how can we provide y prime from the causes side of the boundary? So it found that actually its y's can be represented from the cause side of the cause case using the so-called James formula. So next I will talk a little bit about this James formula. So consider you are still using archaical method, and you already made one-time step from yn transform to the archaical method. Then then you can assume that you can have approximate about the u at any time point between Tn and Tn plus 1. And this theta basically going from 0 to 1. So because you are using RK4, then you will have all the KIs to need from the RK4 method. So you assume that the u theta, which is the value, and in between basically you want a bet of u at any yeah, so suppose you already make a complete RK4 but not plus theta t, and you want to ask what kind of u you can have at any point between t naught and t naught plus theta t. So so we can assume that it has this kind of expression, but it's I theta example which can be determined. We require that the expression of this theta is equals to the true solution for the 4. And with this requirement, we can actually have a unique solution of the theta, which is this. So now you have a complete formula up to h to a fourth of accuracy of the expression any time between t naught and t and t plus 1. So other than that, you can also take time derivative, and you will have also an expression for not just yn to also have y prime. So on the cost side, we can, because we know case, that we can use this formula to approximate the y and y prime using this case of the cost side of the between the mesh. So let's go back to this. So as we before in the fine side, in order to fill in the growth point for the fine level, uh, we basically we want to fill in this substage by 1, 2, 4 in the fine growth point. And right now we have and it can be expressed in terms of y and y prime, and and as we just talked before, we can use this dense output for the cost level to approximate this y and y prime on the cost side. And then we interpret the space building a fine growth point. Then we can perform. So here's a sketch for the subcycling. So actually, in order to instead of using the buffer zone and the throw out actual point, we are just using the data of the coarse grade and doing using this dense output to fill in those points, which will be used finally. So because we are using the coarse grade directly to fill in all these coarse points, so we don't need to actually put a bubble point. Right, that's basically what we want to implement in CarpetX. So we clearly have this advantage. It has smaller number of buffer zones, which has mesh requirement boundaries. And we hope that we hope it can scale it better. And because of you can see all the formulas use up to H2 force. So it will be first of converted. So we also expect that the community implementation has also conversion compared to the second cut. So next I will try to show some tests backed on with the new implementation set CarpetX. First, we try a scalar wave. It's a triple scalar wave, which have a pulse at the center, starting from away from the center. And these two tests are done at Carbet by turning on and off subcycling. And this is the radial direction, and the y-axis is basically the arrow, numerical arrow, the evolution. Given these three given lines, given curve, correspond to the resolutions, and we assume both all the convergence and the arrow agrees pretty well between these three things. So this is without subcycling, so with subcycling have the same convergence. First of all, that's the first catch. And the next we tried minor track concentration with one function. And here I show the GXS component matching YY matching. And the two level are based at the X equals 4. And as you can see, I'm sorry, this plot is not. Yeah, I'm sorry.
These are different metric components. I
Yeah,
can't just see it.
That's GXX and GXY. Oh. Given the component after 256 steps, and I'm using two different color representing recent without subtracting case, and you can vary down the difference between these two cases. Basically, what we want to show is that subcycling, the accuracy of subcycling. The subcycling has no effect. Right. This is level 0, so it's really low resolution. Yeah, I hope, but we have I think 9 levels of one is highest resolution. So this is X. Also, it's Apple the first level, and also different color matching between using and not using subcycling. Also difference. So this is just a we test
5 minutes, please conclude.
Okay. So this is in this case we get the space with the metric evolution with inside CarpetX using subcycling. So next we want also test the group evolution with subcycling. I don't have the evolution yet, but what I'm trying to show here is the TOV stock, magnetized TOV stock, and the y-axis is basically the concentration of the second density of the star and with time. Yeah. And I also compare I also using 2 different colors represent the 2 situations with and without subcycling. Those next are good trials of this implementation. So this is the accuracy of the implementation of the subcycling, new subcycling inside CarpetX. So next, I'll talk about the scaling performance. So this is scaling performance of CPU on Terra. So x-axis number of nodes. Terra, the y-axis is the speed, time per day, physical time per day. And yeah, I showed this problem. So what do we have done for the previous few months? It just got up too high. So as you can see, the blue and the orange are the old Carpet is Michael. We start like now, and the green and the yellow, the green and gray are the runs using say for CISO CarpetX. With and without subcycling. And this dash line, I think, the perfect scale. So I mean, by turning on subcycling, both the Carpet and CarpetX can speed up by a lot. But right now, CarpetX is implementation of the Einstein equation is slower than the Carpet implementation. So next,
2 minutes.
Improve this. Maybe gradually better than. So and right now, I want to emphasize that the current implementation of subcycling is not optimized. So, so that you can see that actually the scaling performance is not so. It's not better compared to that what we want to improve next. Okay, so this is do the Q1 PPH environment. So we also did oh, sorry. This is long plot. I want to give you a clear idea of this.
1 minute.
Using subcycling, not subcycling. So it is green and purple. Right, the green and purple are the CarpetX lines. Improve the almost just give you a chance.
30 seconds, please conclude.
Okay, so we also did a screen test on the GPU machine frontier. So for this case, instead of 9 levels, we tried a specific levels of basically we are using computation from student studied expectations. And so here in the x-axis number of here, the y-axis is time speed. And as you can see, like this, we using we can improve the speed by twice. So the reason is because we have one level, but all right. So what we want to next is again optimize the implementation of subcycling and CarpetX. We want to use a special data structure for the points. Basic those points required to fill in the final application. And we also want to specific things. Right now we're using general things which contains not only the inter-process communication, also the propagation between different levels. So we want it's so sometimes during the subcycling sometimes we only did one kind of things. But right now we're just repeating a lot of things. And so for the fluid part, right now we are next we want to great. Okay, I will stop here.
Question. You talked a bit about, in addition to those the memory challenges for having subcycling.
Okay. So yes, right. So in order to interpret those points, we need to store all the K's of the call cycle. Right now, we are just copy the whole domain. We are just store all the K's, but only required K's are actually these small regions, which will be used for special integration to false point. So right now, we didn't do anything. We just we just store everything. Very bad for that memory performance. So what we want to do next, we just want to store the small region. This final boundary. Then if the goal zone only, I mean, the percentage between the goal zone and interior point is small, then we can expect that this actual storage will not have a large impact on the whole storage. But right now, we don't have enough.
Other question? I don't recall you saying this,
but it's a strong scaling test that you're showing us, right?
Oh, yes, yes, yes.
And I think you promised me a GPU plot. I didn't see that. Oh, that was a GPU?
Yeah.
CarpetX
GPU components or?
Yeah, see, GPU.
Oh, yeah, you're right. Scaling.
So this is CPU.
Right. All right.
This is
And
very
Carpet isn't on here.
Yeah.
I mean, I realize in some sense it's not a fair comparison, but I kind of wanted to see Carpet first. So this is going at like 25.
Oh, right. I can tell you the number. I can tell you the number. So with this GPU machine, we can achieve 3,500, right? So for coverage, what the best we can do is at 300.
Okay.
The maximum, basically the peak, is the from Terra machine. So that's a difference.
Okay, that's what I was trying to
Okay,
get at.
thank you, thank you.
All right. Yes.
Oh, this derivative, right? Yeah. Yeah, we are using this so-called.
Oh, you have to repeat the question.
Oh, sorry. So the question is, how can we prepare this Y primes in order to fill in the both points, which will be required for to evolve the final levels? So the way we prepare this Y prime is using this so-called dense output method. So using this formula, because on the core side, you have K stored, and then because you have basically expression of B's, so using this formula, you'll have Y's, and we also have formula for Y prime. It's only a function of K and B's. So it's a linear combination of K's, and we store K's in the core side of the mesh.
Peter.
So will this only be available for K4 or will this?
Very good question. So it's only efficient for RK4. If you go higher, then I mean, I think it's not possible or it's not worth to that.
That was my question for you.
Oh.
So I tried to look at your original papers a little bit, and then you go on, and they effectively say that if you want to go any higher order than fourth order, you actually have to consider more terms, or you have to be lucky enough that the right-hand side is not.
Okay, let me.
Okay.
Okay, I think I remember something. Let me show.
Yeah, I will live. I'm pretty sure.
What is what I died, Roland?
So when you're trying to represent the Y's with with the Y prime. So when you're trying to represent the Y's with Y prime, actually there's a special term called Y, Fy, and Y prime prime. Only this term can be represented with a case. If you're trying to go to higher order, then you will have actual term, which will be really complicated, not that simply you can do it in this way. I think that's the special of RK4, and you can do this way.
I was also thinking about RK3.
Oh, yeah, okay. So RK3 is fine. If you're going this way, then it's fine. because the first few terms it can be represented with K.
But we don't have that influence.
Not yet.
Similar question. Can you translate this into like a shoe and these are like represented as butcher tempo. What about like a shoe butcher form? Express this in terms of alpha potatoes.
Sorry, I cannot answer that question.
Okay. Well, let's talk later, right?
Yeah.
I'm reading grasp.
All right, any other questions? All right, let's thank the speaker again. And let's see if lunch is ready. Should be.